Okay, let me ask you something. What if I told you there are places out in the universe, places where time itself just completely breaks down and not even light can get away? Well, that's exactly where we're going today. We're taking a journey right to the edge of space-time to get to know one of its biggest, baddest mysteries, the black hole.
That might sound like something straight out of a movie, but it's not. It's the real deal. Black holes aren't some kind of science fiction monster, but man, do they mess with our heads. They totally defy everything our intuition tells us about how the universe is supposed to work.
All right, first things first, let's get one huge misconception out of the way. Black holes are not cosmic vacuum cleaners just roaming around, gobbling up everything in sight. Nope. The reality is actually way more elegant. They're the quiet, final chapter for some of the biggest stars out there.
So let's start our journey by figuring out what these things really are and where they come from, because they're not just some random cosmic weirdos. They're a totally fundamental piece of the puzzle that is our universe. So what's the core idea? Basically, a black hole is a spot in space-time where a mind-boggling amount of stuff has been crushed into a teeny tiny space, and that creates a gravitational pull so powerful that once you cross a certain line, that's it. There's absolutely no coming back. Not for a planet, not for a star, not even for light. So how does one of these things even get made? Well, it's one of the most violent, most spectacular shows in the entire universe. It all starts with a massive star, way bigger than our sun, that runs out of fuel. At that point, gravity takes over and wins the fight. The star's core just collapses. All the outer layers get blasted out into space in this insane explosion we call a supernova. And then, if the core that's left behind is heavy enough, gravity just keeps crushing it and crushing it until, poof, you've got a black hole.
Okay, so here's a good question. If black holes are, black, how on earth do we even see them? The trick is, we don't see the hole itself. What we do see are the absolutely incredible, blazing hot structures that form right around it. And this right here, this is the main light source we're talking about. See, when gas and dust get pulled in, they don't just fall straight into the abyss. Instead, they start swirling around faster and faster, forming this superheated, glowing disk. It's kind of like water swirling down a drain, but way hotter and brighter. We call this the accretion disk. And get this, sometimes a little bit of that swirling stuff doesn't fall in. Instead, it gets shot out from the poles in these two unbelievably powerful jets. We're talking jets of material blasting away at nearly the speed of light, stretching for hundreds of thousands of light years into space. It's wild, and honestly, scientists are still trying to figure out exactly how these massive things get launched. You ever see a picture of a black hole and notice how the disk looks all lopsided, brighter on one side? Well, there's a really cool reason for that. It's an effect from relativity called Doppler beaming. Think about a siren on an ambulance, how the pitch gets higher as it comes toward you. It's the same idea with light. The part of the disk spinning towards us looks brighter, and the part spinning away from us looks dimmer. Simple as that. All right, now we're getting to the really good stuff. We've arrived at the most famous, most mind-bending part of a black hole, the point of no return. This is where physics as we know it gets pushed to its absolute breaking point. So what is this point of no return? Well, it's exactly what it sounds like. It's not a wall you can touch or anything, but if you cross it, your fate is sealed forever. This one-way door has a name, the event horizon. And again, it's not a physical surface. It's just an invisible line in space. It marks the spot where the pull of gravity is so strong that to get away, you'd have to go faster than the speed of light. And since we know nothing can do that, well, nothing that crosses the event horizon is ever coming back. There's a great way to think about this. Imagine you're in a canoe on a river that leads to a giant waterfall. Far upstream, the water is calm, you can paddle wherever you want, no problem. But as you float closer to the edge, the current gets faster and faster. Eventually you cross a line where the water is moving so fast that no matter how hard you paddle, you can't go back. You're getting pulled forward. That line, that's the event horizon. And once you're over the edge of that waterfall, you're going down. And this is where things get really weird, thanks to Einstein. Let's say you're the one falling in. For your friend watching from a spaceship far away, they would never actually see you cross the event horizon. To them, it would look like you're slowing down, getting redder and dimmer, until you just seem to freeze at the edge, faded into nothing. But for you, everything would feel totally normal. You just float right across that invisible line without feeling a single bump. The only difference is, now you're inside, and every possible path you can take leads to one place, the center.
So, what happens after you cross that one-way door? What awaits you inside? Let's take the plunge and find out what theory tells us is the final fate for anything that falls in.
Once you're inside, your fate has a very descriptive name. It's called spaghettification. Seriously, imagine you're falling in feet first. The pull of gravity on your feet would be so much stronger than the pull on your head that you'd get stretched out longer and longer while being squeezed in from the sides. You'd literally be turned into a long, thin strand of, well, you get the idea, a human noodle.
But hold on, here's a crazy twist. When this spaghettification happens actually depends on how big the black hole is. For a smaller one, say the size of a star, those stretching forces, the tidal forces, are so extreme you'd get ripped apart before you even got to the event horizon. But for a supermassive black hole, one of those giants at the center of a galaxy, the stretching force at the event horizon is much gentler. You could actually cross it totally fine, completely unharmed, and only get turned into spaghetti much, much deeper inside. Wild, right?
So where does this spaghetti end up? It all heads to the singularity. This is the theoretical heart of the black hole, a point with basically zero size but infinite density. And it's right here that all our known laws of physics just stop working. They break down completely. This is the place where relativity and quantum mechanics go to war. And it sparks this huge debate among scientists. What happens to all the information that falls in? Is it just deleted from the universe forever?
Okay, let's pull our view back out of the abyss for a second and look at the bigger picture. Why does any of this matter? I mean, why take this crazy journey to understand such a bizarre object? Well, it's because black holes aren't just strange things out in space. They're like cosmic vaults, holding on to some of the deepest secrets of the universe.
Studying them is a lot like being a cosmic detective, right? You can't see the suspect directly, so you have to look for clues. You piece together the story from how it affects everything around it, the light, the way stars are moving, even the ripples it makes in the fabric of space itself.
And we've gotten pretty good at finding those clues. We can actually see stars whipping around an invisible point at unbelievable speeds. We can see that brilliant, telltale glow of an accretion disk. We have even, amazingly, managed to take a picture of a black hole's shadow against that superheated gas. And now, we can even listen for the sound of two black holes crashing into each other by detecting the gravitational waves, the ripples in space-time that they create.
When it comes down to it, black holes are so much more than just cosmic curiosities. You could say they're nature's ultimate laboratories. They are the absolute frontier of what we know. They're the one place in the universe where our two grandest theories, Einstein's relativity, which describes gravity, and quantum mechanics, which describes the super-small, are forced into a head-on collision. And figuring out what happens right there, at that intersection, that could be the key that unlocks the next giant leap forward for all of physics.
So, in the end, they connect everything. The tiniest particles to the biggest structures. The death of a single star to the silent, gravitational heart of an entire galaxy. They're not just empty holes in space. They are windows, giving us a peek into the very soul of the cosmos. So the next time you look up at the night sky, remember those invisible giants are out there. And just wonder, what secrets are they still hiding?